Here's an acrylic prototype that I made for the lower arm section. This was mainly to test how well this built-in tube system was going to work, or if it was going to work at all, really. And I made it out of acrylic because I have quite a lot of acrylic and it's very easy to work with. But now that I've seen how it fits together, I think acrylic could actually be the final material for this section. It doesn't really need to be that strong, and it fits together really well. Like, it fits together so well that I haven't bothered to even put screws across here to hold it together. I've just sort of squashed the tabs in. Fortunately, everything fit in exactly how it was supposed to, and it holds together quite well just like that. Good enough to, you know, pick it up and move it around and just handle it a little bit. Got to be gentle with it, but you know, it holds together pretty well without screws, which is nice. Anyway, so the front section there is looking like this, and the other nice thing about acrylic is you can see through it, so you can see what's going on in that section inside. Well, that's a little bit hard to see on video, but you can see that the aluminium standoffs there are functioning as rollers. So I can just maybe move this a little bit. There we go. They are actually rolling because I drilled out the thread from the middle of them, so there's no thread inside. They're just free to roll on the screw that they are around. Trouble is though, when you drill like that, it's quite hard to get it straight. So as you can see, it's sort of wibbling and wobbling from side to side. And it also has this really annoying click at some point. Maybe you can hear it, I don't know, but it goes click. So I think what I'll do in future is use nylon or plastic, sort of a spacer thing for this instead of aluminium, and then I won't have this annoying click, and it will roll without squeaking too, because it squeaks sometimes when it moves as well. But you can see that the gear wheel is meshing quite well, and it's actually fairly easy to move. So this is about a 3:1 gear ratio from here to the stepper motor at the back. And we have the same kind of thing at this end. So there's the two aluminium spacers. This is actually quite a bit easier to move, of course. And it actually works reasonably well, but not well enough that I wanted to keep it. I just sort of sensed that this would cause problems in the future. I'll hook up the motors and I'll show you it moving in a minute, so you'll see that it does actually work reasonably well. But it's just so borderline, you know, potentially problematic in future that I'm not going to go with this. Now, when I tested this before, I think where it is here is the neutral position. So when I twist it round like that, I'm actually starting to twist the belt on itself inside the tube. But when it's here, I think it's pretty free to move. And when I was testing, I managed to get about 1.5 turns each way before I started hearing clicking and getting problems and stuff. So I could go one. No, that doesn't feel right. Oh, maybe this is neutral. That might be neutral there. So let's tip it up that way. Anyway, but you could get pretty easily, you could get a 360-degree range of motion before the belt started to cause any trouble. Yeah, that's the center there. That's nice and easy now. Anyway, let me hook this up and I'll show you how it works. Actually, now that it was about a week ago that I tried this, I don't remember it being that smooth, but seems to be working quite well. You can just see it's wobbling a bit like that. That's just because the mass of the motor at the front is moving, so it just sort of wiggles a bit. Let's see that again. Yeah, so just hold it that way. See that everything looks alright. Actually, this is not too bad. So this time let me try and twist it while it's running. I'll twist it 180 degrees round. Whoa, didn't like that. What? Wrong way? This way. 360 degrees that way. There we go. $360. Hold it there. Okay, so it is feasible to get a 360 degree range of movement on this axis and still have reasonably good freedom of movement of this axis, but it's just kind of a bit dodgy, you know, so I don't think I'm going to go with that with this small pipe. At least I want to try it with a large pipe and see if it improves anything. So this joint at the top, I mean this motor, oops, falling apart. So the way this is going to move will be with this motor through there, of course, and I'm going to put this gear on to the pipe. And originally with my old design I was using this kind of a gear here, but this weighs 39 grams and takes up a lot of space in this direction as well. So what I wanted to try and do was make my own gears like this and have them go over this pipe. So this is a 12mm bore, 12mm pipe, and grip onto the pipe. But I wanted to make them out of acrylic so that they weren't going to be heavy. But in order to grip onto the pipe, they needed to have a grub screw. So that's how these work. They have a little grub screw in them like that, and that grips onto the shaft of the motor or whatever it is that you're sticking it onto. And I don't think that grub screws in that situation would work very well in acrylic. So what I've done here is I've sort of mixed, and I have the best of both worlds. So most of the gear is very light acrylic, well, light compared to aluminium, and then just for those important parts where the grub screw goes, I have machined a little bit of aluminium just to hold the grub screw, basically. So if you look at it from this side, you can see they don't actually go all the way through. There's acrylic, there's 0.5 millimeter of acrylic on there, so that's a 6mm thickness of acrylic and 5mm thickness of aluminium, and then there's 0.5 millimeter there, and then there's 0.5 millimeter indent there. You can just sort of feel it when you put your fingernail on it. So yeah, done very carefully. That ended up to work very, very well. And this weighs 9 grams instead of 39 grams. And you just put a little Allen key in there, turn that, and then the grub screw comes out there to grip onto the shaft. Very nice. So this works fine. Not really, wasn't really anticipating any problems with this, but I'll just put this in and show you how that works as well. Here's how that one would look. Whoops. This clamp is actually supposed to be clamped on up there to hold that bearing against that front plate, and the gear itself here doubles as a clamp to hold the back bearing against the back plate. Anyway, so you can see it's having no problem at all turning that. Well, I was hoping to show you both of these motors moving together, but just doesn't seem to want to do it. Kind of doing it, but doesn't get all the way with the front part. No. So I think I'm just really pushing it to try and expect a 6mm wide belt to go back and forwards inside a 10mm inside diameter pipe. Yeah, it was worth a try, I think, but now we know it's not really going to work. So even though that belt within pipe system is looking a little bit dodgy, let's not forget one of the main reasons that we were doing that. Let's check the weight of this, because it's a darn sight lighter than the 780 grams or whatever it was to begin with the plywood thing. So it's 462, and I'm going to have to put a couple of big bearings on there. Less than 500 grams, with no end effector at the moment, of course. And there's probably a little bit more to go on because we're going to have some long screws here. So say around about 500 grams. So as you can see from that, we're starting to get towards something that's actually workable. But yeah, there were a few issues still. So what I thought I might do next is just make it roughly the same, except make it use a much larger pipe. This is a 30mm outside diameter pipe here, and basically the rest of it's kind of the same. You can see I've changed a few bits and pieces here. I have drawn some proper gears. These are the actual correct tooth numbers of gears that I'm going to be using, so that enabled me to see how they fit in there. And now that this thing at the front is riding on or mounted on a 30mm diameter pipe, it's going to be quite a bit wider. So it's actually wide enough to fit the final stepper motor inside the middle of it and keep that on the same axis as the final part of the arm itself. So if we look right down the axis of the stepper motor like this, we're also looking down the same axis as this part of the arm. So that makes the calculations a little bit simpler, or it makes the setup for the calculations a little bit simpler if everything's just on the same axis. And I also like the fact that it looks, whoops, here we go again, doesn't matter what it looks like, but it's symmetrical. Isn't that cool? I just kind of like that it's all symmetrical instead of having the motor hanging off to the side. So apart from that, I have not changed anything much, but once again I did make a prototype at this point, so I will I think that's all the SketchUp that I have to show you. This is as I make this on the 11th of November, this is my current design, so I still have some prototyping to do before I come back to this and fix my mistakes.